Today, we're going to have a very unusual episode because it's all about hardware. Specifically, mini PCs for AI and SAP. We'll take a look at several computers, even from the inside. I'll say a few words about Google Coral. I'll even invite you to my basement. I will discuss the advantages of the Intel N100 and explain why it outshines the famous Raspberry Pi. We'll run a large language model on it and see how much power such a mini PC consumes. Of course, this is just my point of view. Now, if you have your own opinion, feel free to leave a comment, and while you're at it, subscribe to the channel and give it a like. Let's get started. If you watch my channel, I bet you recognize this desktop. That's right. Most of Sapdolf's videos are recorded on a mini PC. Of course, this isn't the only computer of this type that I use. Let's take a look at its specifications. If we look at the specifications, it's easy to see that my mini PC is based on N100. The 800 MHz is a bit misleading here, because the processor reaches over 3 GHz. The computer in this version has 16 GB of memory, and interestingly, it's DDR5 memory, which is quite unusual. OS is Windows 11 Pro. Windows is, of course, activated without the slightest issue. The configuration contains also a 500 GB SSD drive. You're probably wondering what's so special about the N100 processor. Let's first take a look at its specifications. This is a mobile processor from Intel, manufactured using quite modern lithography. 4 cores, over 3 GHz, and only 6 watts thermal design power. It's no longer the latest processor, as it was released in the first quarter of 2023, but it is very affordable. Interestingly, the manufacturer claims that the processor supports only 16 GB of RAM, which isn't entirely true. It can be either DDR4, as is the case with most of cheap mini PCs, or DDR5. The chip also features an integrated graphics card. Of course, this isn't a processor meant for gaming computers, so I won't even attempt to run games on it. However, you can easily watch 4K videos on it thanks to hardware support for decoding. It can also handle up to 3 displays. Looking at the specifications, you can probably guess that this is a modern processor that prioritizes energy and cost efficiency over top-tier performance. And those are also the 2 main advantages of mini PCs based on this chip. The CPU already has a successor called the N150. However, it is more expensive than the N100 and doesn't offer a significant performance boost. So at this point, the N100 is still a good choice. I mentioned that the N100 series processors support a maximum of 16 GB of RAM, at least according to the manufacturer. This isn't true, as you can see in my video where I install the SAP system on the Firebat AK2. To do this, I expand the memory to 32 GB. This configuration has been working flawlessly for quite some time. When discussing the use of mini PCs, it's hard not to touch on the topic of performance. I'm not a fan of synthetic benchmarks, which often don't align with the user experience, especially when it comes to interactive work. However, the results of these tests can certainly tell us a lot about the processor itself. I installed Cinebench to run some tests. Of course, I'll conduct them and present the scores for both multi-core and single-core tests. Since the test is quite long, especially on slower computers, I will speed it up significantly. So, what are your bets on how this budget processor from about 2 years ago will perform? Please remember how low its energy consumption is. And there you have it, we have the first result, 2,927 points for the multi-core test. Of course, the score itself doesn't say much, unless we compare it with other processors. As you can see on the left, it significantly lags behind today's top class. But this is a budget CPU. We also have the result for a single core. It is 924 points. How do these results compare for our N100? It's roughly on par with the performance of the rather old 6th generation i5 CPU, or a mobile version from 8th generation. Considering that the TDP of the N100 is 10 times lower than that of its older sibling, I'd say that's quite a good result, especially since the N100 supports modern memory and its chipset is capable of decoding advanced video algorithms. In my opinion, the user experience is even better than the test results. The mini PC market is highly competitive, with many manufacturers producing models with the N100. As a result, prices are low and currently start at under $100. Should you only consider the price? I would say largely yes, but you also need to look at your needs. To help you know what to look for, I'll present 4 example models that I own. This is the Firebat T8 Pro, the smallest of the models presented. It features 3 HDMI ports, so if you want to connect 3 monitors, this might be the choice for you. It also has 2 2.5 gigabit Ethernet ports. Bluetooth and Wi-Fi 6 is a standard in these computers. If you choose the Firebat with the 16 GB version, it will come with DDR5 memory. Unfortunately, it is soldered onto the board, so you won't be able to upgrade it. The mini PC is powered by a 12-volt power supply, just like all the ones presented here. Let's take off the cover to see what's inside. First, unscrew the 4 screws from the bottom, which is very simple. You just need to get a good tool and problem solved. Just don't lose the screws, because they tend to fly all over the room, and then they're hard to spot. And now comes the part I really dislike: snaps and prying, as if they couldn't make it more user-friendly, so it could be easily taken apart. Don't get me wrong, but this mini PC is the hardest to disassemble of them all. Maybe it's embarrassing that I struggled with it for so long, but I finally managed to do it. This cover basically does nothing. Another one with a fan appears, and you have to unscrew another 4 screws. But that's much simpler now. You just need to be careful not to damage the wires from the antenna and the speaker, which are glued to the top casing. You have to do it very gently. And that's how we get access to the SSD. You can easily replace it without any trouble. Just make sure to pay attention to the size. I'll unscrew it to see what's below. By the way, there's also easy access to the fan in case it needs to be replaced. In mini PCs, the cooling system is usually similar to what we know from laptops. Let's get back to the disk though. I need to remove it from the slight tangle of antenna cables. And done. I can still remove the Wi-Fi card and disconnect the speaker. This way, I'll be able to completely dismantle the casing. By the way, the Wi-Fi card can easily be replaced with something else, like a Google Coral, but I'll talk more about that in a moment. As you can see, it wasn't particularly difficult, although compared to other mini PCs, it does require a bit more effort. One drawback is the non-replaceable memory, but with 16 GB, it is DDR5, so better than others. The next mini PC I would like to introduce to you is the SOYO M2 Plus. This is the only computer from these 4 that comes with a pre-installed 2.5-inch SATA drive. However, it has as many as 5 USB ports, including 4 that are USB 3.2 standard. Let's disassemble it. At first glance, the computer looks very solid and is quite heavy. It's also noticeably larger than the Firebat T8. To open the case, you first need to unscrew the 4 small screws at the bottom part of the enclosure. This is pretty standard. After that, you need to pry open the bottom part of the case using a special slot. It's not particularly complicated and is quite quick. Be careful when opening it to avoid damaging the SATA cable, which is rather delicate. And now you have access to all the components you might want to replace. First and foremost, you have the 2.5-inch drive. This small expansion card is responsible for wireless communication, but I use wired connections when I can. You've also got a free slot for an SSD here in case you want to replace or add storage. Here is the mounting screw for the disk. And of course, the RAM slot for DDR4 memory. Replacing the memory is very simple. You just take out the old one and insert the new one, and that's it. If you've ever replaced memory in a laptop, it's basically the same thing. A really well thought out design. I like it. But let's move on to the next mini PC. Another Firebat, this time the AK2. From the outside, it doesn't stand out in any particular way. Certainly not in terms of design. It doesn't have too many ports either. Let's take a look at what's inside. And here we see the first great feature. Just slide the small lever, and you can remove the top cover. Underneath the cover, you'll find a space ready for connecting a 2.5-inch SSD, so we can easily expand the storage. And when we unscrew 3 additional screws, we can go further and see what's under that disk holder. And here we have a RAM module in the slot. Of course, it's DDR4. We can easily expand the memory. So, who would this mini PC be recommended for? Primarily for those who don't pay much attention to design. Instead, they want an easy way to add an extra SATA drive or upgrade the memory. And now one of my favorite mini PCs, GMKtec G3. It's not rich in ports, but it's small and its design isn't bad. But the most beautiful part is how you can disassemble it. And that's it. The perfect design. Why can't it be like this everywhere? You can see a long SSD here, and below it, a traditional wireless card. Both of these components can be replaced. Additionally, there's an extra empty slot where we can install something like a shorter SSD. There is also a DDR4 RAM module from a well-known company. For me, it's amazing. Although my favorite mini PC is still the Firebat T8 Pro. We don't disassemble a computer every day. But kudos to GMKtec. Since we're already talking about disassembling mini PCs, it's worth mentioning Google Coral. It's a tensor processing unit module that provides inference processing for machine learning. You can buy it as a card with an M2 interface and install it in a mini PC, for example in place of a wireless card. I installed these modules in my Firebat T8 Pro computers. What can this be used for? For example, for AI-based monitoring, with the detection of various people and objects. In my case, for instance, my smart home opens the gate's electric latch when someone approaches it from the yard side. This brings us to the broader topic of applications of mini PCs, apart from monitoring, which I have already mentioned. The possibilities are very broad. The first and most obvious use for a mini PC is as a computer for entertainment and work. While it won't run the latest games, since the built-in graphics chip isn't very powerful, it's perfectly adequate for tasks like browsing the internet or office work. Considering that you can easily mount such a mini PC on the back of a monitor, it makes for a very sleek solution. And contrary to what you might think, it's sufficient for most users. And if you want to discover more applications, just take a look at my YouTube channel. Here's a video where I install my SAP sandbox. Yes, these computers are powerful enough to be used as a one-person experimental SAP system. Moreover, you can complete the installation in less than 30 minutes, as I demonstrate in this video. Later on, I also performed an upgrade, which you can see in this video, and you probably recognize the Firebat AK2. The mini PC was also used for front-end related projects. Notice that I used such a computer to create a SAP agent as well. Here, everything, including this SAP GUI and the agent itself, runs on a mini PC with an N100 processor. I have no problem using such a desktop for programming, especially when I need to demonstrate what the process looks like. On a daily basis, I use Linux, but I want to show it on Windows, which is more popular. A mini PC with an N100 processor is a great choice for a smart home system, although I personally use a Raspberry Pi for historical reasons. If I were starting to build such a system today, I would definitely go with the N100. Moreover, some of my Docker containers are already running on the mini PC, along with the monitoring system. I'll talk more about energy efficiency in a moment. And if you still have doubts, go ahead and check out all the videos on my channel. With very few exceptions, they were created using a mini PC, specifically with the N100 processor. You know well that I also use my home lab for various AI-related tasks. Although in most cases I use APIs and remote models, there's nothing stopping me from running a small language model on such a mini PC. Let's see how it works. I'm curious myself. This is actually a GMKtec with 8 GB of RAM, so it won't be able to run a very large model, but a 3 billion parameter model is definitely within reach. I have the Ollama installed and 2 models downloaded. Llama 3.2 with 1 billion parameters and 3 billion parameters. Both are with 8-bit quantization. I'll run the larger model for now. The verbose option will provide me with information about the exact inference speed. I will ask the AI who a SAP basis administrator is. Now, it's up to you to decide whether the response speed is satisfactory or not. Keep in mind that this is a small LLM, so it would run noticeably faster on a more powerful computer or a graphics card. However, I believe that for certain applications, both the intelligence of such a model and its inference speed would be sufficient. And if the speed is too slow for you and you specifically need a larger model, you can always consider purchasing a mini PC with a better processor and more RAM. You can get a mini PC even with really modern CPUs, such as the latest series of AMD Ryzens, which also support AI. Of course, it's all a matter of price as well, because a more advanced mini PC won't cost just $100, but more. Alright, the response has been completed and it took a minute. The inference speed was 6 tokens per second. In my opinion, that's quite good. And sometimes you don't even need 3 billion parameters. Let's see how a model with 1 billion parameters performs. I'll ask it the same question and we'll see if it's faster. I'm loading Llama 3.2 with 1 billion parameters. Of course, in 8-bit quantization, as I mentioned earlier. As you can see at first glance, AI responds faster than before. Obviously, I don't expect the response to be just as good. Ultimately, we have the result, 15 tokens per second. That's really quite good. By the way, as you can see, this mini PC is running Linux. It's the latest version of Debian. In my opinion, many people can easily use Linux instead of Windows these days. It's just as intuitive and user-friendly. At the beginning, I promised to show you my home lab in the basement. Here it is, welcome. This is proof that I actually use the mini PCs on a daily basis. Here's my Styleflex rack cabinet, a piece of solid metal. The mini PCs are running here all the time. Of course, electricity consumption is quite important to me in this case. Therefore, it's worth moving on to summarizing energy efficiency. Since mini PCs are powered by a 12 volt, I had no trouble connecting the Firebat T8 Pro to an universal power supply. As you can see, when nothing is happening in the system, it is content with just 5 watts of energy. When I play a video on YouTube, the situation doesn't change all that much. As you can see, it's an energy-efficient processor, and it also supports hardware video decoding. Yes, I know it's a rather static video, but it really is playing. I'm currently playing 3 videos simultaneously. You can see that the energy consumption is slowly increasing, but that was to be expected. Still, you'd have to admit that it's quite low. Below 10 watts for a computer that's actually doing something is quite a good result. However, when we fully load the computer, the power consumption increases to about 17 to 18 watts. Given this performance, it's still a very good result. Of course, this is the consumption with default settings, without any changes in the BIOS compared to what was delivered by the manufacturer. And if you're wondering how much power such a computer will consume when the monitor is disconnected and it's in idle mode, here's the result. This is important when considering using a mini PC, for example in a smart home system where it will be running 24/7 and not really doing much for most of time. Values between 4 and 5 watts are truly impressive, and we're entering a territory that was previously reserved for the Raspberry Pi. By the way, from my observations, Linux operates more stably and consumes less power in such mode, but I think I've already mentioned that I'm a Linux fan. In any case, I think few people install Home Assistant on anything other than Linux. By the way, you might also consider containerization or virtualization. A mini PC is great for this because it offers enough power for many applications, but don't overdo it either. As I mentioned before, mini PCs with processors like the N100 have really encroached on the territory traditionally reserved for the Raspberry Pi. I have a lot of respect for the Raspberry Pi Foundation and for everything they've accomplished over the years, bringing joy to so many people. However, the emergence of mini PCs priced around $100 is quite a breakthrough, definitely a significant change. Especially when we consider how much a Raspberry Pi costs in a similar configuration. And let's not forget that you still need to buy additional items like a case, a drive, or a power supply. These are quite significant expenses. Feel free to compare the costs yourselves and let us know in the comments what you think about it. Of course, I'm aware of the advantages of Raspberry Pi, and I know that in certain projects it can't be replaced by a mini PC. I also think that the x86 architecture might not always be the leading one, and the world might indeed move towards ARM processors. However, I have doubts about whether this shift will definitely include Raspberry Pi. But a mini PC is also an alternative to the cloud, at least for computer geeks who can manage running services, install an operating system, and applications themselves. If we compare the costs, it's quite likely that maintaining a mini PC will turn out to be cheaper. In reality, it's important to understand the capabilities, strengths, and weaknesses of each solution, and choose them according to your needs, and sometimes even combine them. This was truly an unusual episode, and I pondered for a long time whether to record it at all. But I figured it might be useful to someone and interesting to see a piece of my home lab. Of course, I can show more in the future if there's interest, although this channel doesn't focus and won't focus on hardware. I'm curious about your comments. Was it interesting at all? May your hardware always be fault-free. See you next time.